Hello there, pre-algebra students. This is Chapter 6.5, Similarity and Measurement. Earlier in Chapter 6, we identified similar figures. Now we're going to use what we know about similar figures to find unknown side lengths. Let's get started. We'll begin by finding an unknown side length in a similar figure. Given that ABCD is similar to EFGH, find line length EH, or X as it's labeled here. So we're going to use ratios of the lengths of corresponding sides to write a proportion involving our unknown length EH. So let's write a proportion that uses BC to FG and set that equal to AD over EH. Now let's substitute in the values that we know. BC is length 12 inches. FG is length 30 inches. Line AD is 16 inches. And EH is X, the quantity for which we're solving. Now we're going to cross product property multiply to get 12X equals 480. And then solve for X to get 40. So the answer is that line EH is 40 inches long. Now work through these two checkpoint problems on your own, using the same process used in our prior example. Another way that we can use similar figures is to indirectly measure lengths that are difficult to measure directly. In this picture, we're going to use indirect measurement to find the height of the cactus. A man who is 6 feet tall is standing near this saguaro cactus. The length of the man's shadow is 2 feet long. The cactus casts a shadow that's 5 feet long. How tall is the cactus? As the man and the cactus are both perpendicular to the ground, and the sun's rays strike the cactus and the man at the same angle, we can form two similar triangles and use what we know about the man's height to solve for the height of the cactus. We'll begin by writing a proportion. The height of the cactus, H, over the height of the man, 6 feet. The length of the cactus's shadow, 5, over the length of the man's shadow, 2. Now we cross multiply to get 2H equals 30. And we know the height of the cactus now is 15 feet. See how easy that was? Use the same technique to solve this checkpoint problem. A cactus is 5 feet tall and casts a 1.5-foot shadow. How tall is a nearby cactus that casts an 8-foot shadow? We have one last example in this chapter, so press pause while you work on this problem and come back when you're ready. Our final concept for Chapter 6.5 is to use algebra and similar triangles to solve for an unknown length. Given that triangle ABC and triangle DCE are similar, find length BE. Okay, so let's begin by writing a proportion. Line AB is proportionate to line DE, which is equal to BC over EC. Okay. Now let's substitute in what we know. We know that BC is equal to BE plus EC. So let's substitute that into our problem. AB over DE is equal to, we're going to substitute in the quantity that we know equals BC, which is BE plus EC, and that goes over EC. Next, we substitute in the quantities we know. AB is 20 inches long. DE is 15 inches long. BE is our unknown quantity. EC is 36 inches long. Now we cross product, multiply. Let me give us a little bit more room to work here. So we take 20 times 36 to get 720, and 15 times BE plus 36, which would give us 15. Let's relabel BE as X just to make our job a little easier. And then 15 times 36, which is 540. Okay, now we solve for X by subtracting 540 from each side to get 180 equals 15X. Divide each side by 15 to get 12. So the length of BE is 12 inches. And that wraps up Chapter 6.5 for us. I'll see you tomorrow to do more work on using indirect measurement and algebra to solve for unknown quantities in similar triangles.